Hi there, and welcome back to Mathematical Misconceptions. Today we're going to talk about a mistake that students often associate with inverses, being reciprocals. Now in multiplication, we often interchange the terms inverse and reciprocal to mean the same thing, but when we get beyond multiplication and division, this definition simply doesn't hold. The inverse is defined completely different from the reciprocal of a function, and there are going to be two ways that we can double check that two functions are in fact inverses of each other. In the first instance, when we have an inverse function and we plug it into the regular function, we should just get x. And the second thing that we can also check is that the domain and range for a function and its inverse should always flip. So in other words, the domain of the regular function should be the range of the inverse, and the range of the regular function should be the domain of the inverse. As a reminder, domain is defined as real numbers of x that we can plug in, and range is the output, the y values that we get for the function when we plug in certain numbers of x. And we'll be using examples for today. Now, as a caveat, this is a more advanced video for students who are in Algebra II and above, especially Honors Algebra II and above, who are working with functions and finding inverses. So if you're not there yet, I would say just earmark this for next time, and when you get to it, come back to it and join me so that we can clear up this misconception. If you're ready, let's dive in. Let's go ahead and first define a function. We're going to stick with a linear function today because linear functions are pretty easy to work with. Let's say that we have something such that f of x is equal to 1/3 x plus, let's say, 4/3. Now let's assume that we are using the wrong definition and we define the reciprocal instead of the inverse. Let's say we define f-1, which is supposed to be the inverse, and we say that it's 1 over this whole thing. Now, we're not going to do the algebraic mojo of simplifying this or whatever. We're just going to write it as is, 1 over this whole thing, plus 4/3. Now, let's say we define it like this. We know this is not correct, though, right? It's not correct. We can check this in one of two ways. If I were to plug this entire hot mess into the original function, I'm going to save you the work right now, but if you want to do it as an exercise, that's amazing. It's not going to give you this. It's just simply not going to do it. And you probably don't have time to double check that. Therefore, there's a different way I want you to double check this. Let's analyze the domain and range of the regular function first. So the domain and range of f of x is all real numbers. And this is true for all linear functions. So we can put, let's put real numbers right here and real numbers right here. If we take a look at this function and you have some experience working with what's called a rational function, what is the problem with x down here? Well, there's going to be a value of x such that when you plug it in, it's going to be 1 over 0. And let's go ahead and find that. So let's set the denominator as not equal to 0, which means that we don't want this to be 0 at the end of the day. So the first thing we can do is 1/3 x plus 4/3 cannot be 0. Multiply everything by 3, x plus 4 cannot be 0. And so that we find that x cannot be -4. So the domain for the inverse function that we're trying to get is x cannot be -4. So let's go ahead and erase that a little bit. X cannot be -4. Now let's check the links, right? Do these two links match? And the answer is no. And if they don't match, we don't care what the range is. We know it's just wrong, so we're not going to even pursue that. But if you want to know the range, it's that. In this case, the inverse cannot be 0. So that's for a different video. Now let's go ahead and correct this. So let's erase our work. Go ahead and erase this. And let's figure out how to find the inverse of this function, and then we are going to, in fact, verify that the domains and ranges, in fact, invert and match. Now we have real numbers and real numbers, so what should the domain and range of the inverse be? Real numbers and real numbers. So how do we find the inverse of a function? I always tell students, take this f of x. What's another name for f of x? It's y. Y equals 1/3 x plus 4/3. Now, the next step is the one you have to remember in order to do this correctly. What do we do with y and x? We switch them. We tell you guys, trade places, no arguments, just get to your separate sides. X equals 1/3 y plus 4/3. The name of the game here, once you get to this step, is to solve for y. All right, what's the first thing that we're going to do? The first thing I'm going to do, and you might do this a little bit differently, is I notice that we have this denominator of 3 and 3 right here. I'm just going to multiply everything by 3. So we have 3x. We'll just go ahead and signal it up here so we know our steps. 3x equals y plus 4. And then to solve for y, it's pretty easy. We don't have a fraction to deal with anymore. We just move 4 to the other side. Now I'm going to move y to the left-hand side. So y is equal to 3x, and then we're going to subtract 4, minus 4. And that is the inverse function. And we could see that, is the domain and range all real numbers? Yes. So we'll go ahead and denote that right here. And right there. It's like filling in the blanks. Now, one thing to be careful of is that there are other linear functions that have all real numbers as well. So one thing we have to be careful about is that we need to make sure that this holds true, that when we plug the inverse into the original function, the only thing we should get out is x. So this is now equal to the inverse. The inverse function of x is equal to 3x minus 4. Inverse, not reciprocal. Now, let's go ahead and test two things. Let's go ahead and plug it into here. Let's color code these just to make things a little bit easier. So our regular function, let's put this one in blue, like such. And then let's go ahead and put our inverse in red. Over here, let's just go ahead and start with the basic definitions. So f of x, our regular function, is just equal to 1/3 x, and then it's plus 4 by 3. Now what we're going to do is we're going to take this function in red, and we are going to insert it in the function in blue. So in this case, we have f of, and then now we switch to red, f negative 1 of x, close it off, equals 1/3. Okay, and now from here, this is where we have to lock in. On the right-hand side here, we have an x, and anytime we see an x, we're going to replace it with the right-hand side in red. I know you may not color code things when you do your homework and tests, but if you can, it might actually be helpful to review this. 3x minus 4, close that off, plus 4/3. Now in other functions, you may see x multiple times. So if you parachute it by putting in the red function like this across the board, it may help you see that, oh, that's what I just need to do. Now, the name of the game is that this should simplify to x. So the first thing we're going to see is that we're going to distribute the 1/3, and the 1/3 is going to cancel the 3. So far, so good. So we have the reciprocal against the original value, which just gives us x. We're going to go back to black. All right, so this is going to be equal to x minus 4/3 plus 4/3. And then, of course, what's any number minus itself? It's 0. This is equal to x. So this checks out, and it's great. You may not be convinced from that that's an inverse, but this is more of a catch-all situation. So let's use some specific situations, right? So let's take the original function, and let's plug in a number. I'm going to plug in, let's say, I want something easy. How about 3? So let's say f of x, I'm sorry, we already defined f of x. We're going to plug in 3, right? F of 3, which means plug in 3 for x, is equal to 1/3 times 3 plus 4/3. All right, we just go through the algebra. I'm going to keep this as a fraction, so 3/3 plus 4/3, getting a little bit ahead, is equal to 7/3. All right, so in this case, what is our input? Our input here is 3, so as an ordered pair, it's 3, comma, what's our output? 7/3. Now let's compare that to the inverse function. So When we use the inverse function, how do we verify that this is in fact an inverse? Well, we look at the output of the original function. And so the output of the original function is 7 by 3. I'm going to go ahead and write this function first, as is, just so you can see it. F negative 1 of x is in fact equal to 3x minus 4. Now, name of the game, once again, is go to the blue ordered pair, 3 comma 7 over 3. 7 over 3 is our output, and we are going to put our output as the input of the inverse. And what should happen? We should get 3. Let's see if it works. So the inverse function of 7 over 3 is equal to 3 times 7 over 3 minus 4. Now, 3 times 7 over 3 is just going to cancel the 3's, so we are left with 7 minus 4 is equal to 3. So that means for our input of 7 over 3, we do in fact have an output of 3. So what happens? The input becomes the output, and the output becomes the input. And that's how you can clearly identify whether you have an inverse function or not. X's and Y's trade places. It's very simple. Alrighty, everybody, that was mathematical misconceptions with mistaking the inverse of a function to be the reciprocal and what not to do, and how to verify that you in fact have an inverse function. On tests, you may not have a ton of time to do it, so do the way that you think works best for you if you're not sure you produced an inverse function correctly. If you have any questions, please drop a comment below, whether if it's on this mathematical misconception or something else, and I will see you in the next video. Thank you.